Hey guys, this is the video lesson for the inquiry lab on something called the distributive property. So what we're going to do in this first investigation is we're going to explore solving the type of problem that you see right here using something called area models. And you know area of rectangles is length times width. So let's start off by reading the problem up here. It says, 3 friends are going to a concert at the fair. Oh, that should stay zoomed. Okay. They each want admission to the fair, which is $6, and admission to the concert, which is $22. What is the total that the 3 friends will spend? So here's some important information here. There are 3 friends, and they're each going to have to pay $6 to get into the fair, and they're each going to have to pay $22 for the concert. Now, if we want to find the total that they'll spend, we're going to write this expression below. So take a look here in step 1. Right here we have the 3 friends, and this means we're going to multiply it by whatever the fair admission is plus whatever the concert admission is. So remember, the fair costs $6, concert costs $20. So whatever that is, we're going to multiply it by 3. Now what we're going to do is we're going to set up a problem that's using area models to help us understand 2 ways we can solve this problem. So the first is we're going to draw a rectangle. We'll look at method 1. And here's what it is. So take a look here. This 3 represents the 3 friends. And we would multiply it by the $6, remember that's to get in the fair admission, plus the 22. Now if you think of this as a big long rectangle, if we wanted to find the area of this rectangle, we would have to do the length times the width. So in method 1, since you see how we have 2 rectangles, we have a tan one and a blue one, is we already have the length as 3, but the width is in 2 pieces. So in method 1, we would say, why don't we add these 2 numbers together to get one total width? And 22 plus 6 is 28. So instead of looking at it as 2 pieces, we're going to say the whole thing is 28. And then to find the area, we would do 3 times 28, and that is 84. So that represents solving the problem this way. Remember, 3 friends, they're each paying to get in the fair, they're each paying for a concert. So this is saying if we add up the 6 and 22, just like we did up here, we would say this $28 is what they're each going to have to pay. Remember, it's the total of the getting into the fair and paying for the concert. And you would have to multiply 28 by 3 to get 84. So, just to summarize method 1, we add what's in parentheses, and then do 3 times 28, which is 84. Now method 2 is a little bit different. Instead of adding those 2 numbers together, what we're going to do is we're going to separate our rectangle into 2 separate rectangles. So take a look down here. This is saying that there's 3 friends, each paying $6. There's 3 friends, each paying $22. So in this one, we would find each area and then add those together. So we would do 3 times 6, which is 18, and here we'd do 3 times 22, which is 66. And then we would add these 2 areas together to get our total. And guess what 18 plus 66 is? It is 84. So you get the same thing. So just to summarize what we just did here, I'm going to show you the problem here. We took our problem, 3 times 6 plus 22. Instead of adding what's in parentheses, what we did is we said, let's do the 3 times the 6, and let's do the 3 times the 22. And when we did that, we got 18 plus 66, and we added them together. So that's a little bit different way that you're probably not used to solving a problem. So when we go through this, it says, since both expressions are equal to 84, they are equivalent. So 3 times 6 plus 22 equals 3 times 6 plus 3 times 22. All right, now we're going to go to the next page. And, well, let's go on to investigation 2. Now, this is something totally different. So this is kind of a different type of model, not area models, that we use when we have a variable involved. Okay. So watch this. It says you can also use algebra tiles to model expressions with variables. Refer to the set of algebra tiles below. Now this one says the green rectangular tile represents x. The yellow square tile represents the integer 1. So I call these x tiles and 1 tiles. Now, if we go down here, it says just like 2 times 3 means 2 groups of 3, 2 times x plus 1 means 2 groups of x plus 1. So here's what it means. Here's 2 groups of x plus 1. See our x plus 1, x plus 1. All right. Now, it says use algebra tiles to tell whether the expressions 2 times 2x plus 1 and 4x plus 2 are equivalent. Well, let's take a look at them first. Because you know what? When you look at them, they don't look too much alike. For example, this says 2 times 2x plus 1. This one says 4x plus 2. There's different numbers. There's no parentheses in the one. They don't look anything alike. But watch how algebra tiles work. Now, I'm actually going to go through and I'm going to draw these instead of you following the example. Okay, so I erased everything below so you can see this from scratch. So I'm going to start by drawing this expression. Remember, this means 2 groups of 2x plus 1. So I'm going to draw one group of 2x plus 1. So I draw, here's my 2x's plus 1. Okay, here's my second group of 2x's plus 1. So 2x plus 1, 2x plus 1. Now, to see if it's equivalent, we're going to regroup them. Think of this like a messy locker. You've got x tiles and 1 tiles all mixed in together. When we regroup it, we want to put all of the x tiles together and all of the 1 tiles together. So I'm going to start by drawing these 4 x tiles all next to each other. 1, 2, 3, 4. And then I'm going to draw these 2 1 tiles next to each other. 1, 2. Now notice what we have. We have 4x plus 2 1s. So guess what? They are equivalent. The only difference is on the blue side, we have it organized. This is how you simplify an expression. We're trying to simplify it so all of our x's are together and all of our 1's together. All right. Now we're going to go on back onto the page to page 483 and work on some of these problems together here. Then we'll go on to the other one. So let's start here. This looks kind of confusing, so I'm going to do 1 and 2 with you, and then you'll do 3. In 1, it says work with a partner, draw area models that show the pairs of expressions are equivalent. So this is going to be exploring the idea we just did in investigation 1. And I know there's lines and boxes all over the place, so it can look confusing. So here's what we have. Remember, just do this with me. We have 2 times 4 plus 6 in parentheses. And that was method 1, remember, before. And here we have 2 times 4 plus 2 times 6. So we're going to start with, let's say, this expression here. And that's going to be this side. Then we'll do this expression here, and that's going to be this side. So stick with me. In this, it says, when we have 2 times 4 plus 6, we can add the 4 and the 6 together to get 10. And we would do 2 times 10 to get 20. Okay? Now, here's what that means. Using an area model, the 2 would be here, and the 4 plus the 6 go there. Now remember, we added the 4 and the 6 together to get 10. So the length is 2, the width is 10. 2 times 10 is 20. Now, in the blue side, you're going to do this one with me. This is where, when we had 2 times 4 plus 6, what we're doing is we're going to say the 2 times the 4 plus the 2 times the 6, and we're going to add those together. So the 2 times the 4 is 8. The 2 times the 6 is 12. 8 plus 12 is 20. Same exact thing, right? So remember, we're using an area model. That means we took this 2, and that goes there, and we multiplied it by the 4, which is here. And we got 8 for the area. Then we took the 2 again, which goes here, times the 6 this time, which goes here, and 2 times 6 is 12. So to find the total area, we just added the 8 and the 12 to get 20. All right, so I know that's kind of confusing at first, so we're going to go over one more together. So we're going to start with 2. So we're going to start by looking at 4 times 3 plus 2. And remember, this first method, we add what's in parentheses together. So you ready? 3 plus 2 is 5, right? So I write that there. And what's 4 times 5? 20. And that means we would have 4 times 3 plus 2. And to find the area, remember, you would do the 4 times the total width is 5. Remember, I added those 3 and 2 together. And 4 times 5 is 20. Okay, let's go over to this one. So in this one, what we're doing is we're doing the 4 times the 3, 4 times the 2, and we're adding those together. So 4 times 3 is 12, 4 times 2 is 8, 12 plus 8 is 20. So in this one, we found the area, instead of finding the area of the entire rectangle, we're finding the area of the yellow rectangle and the blue rectangle and adding them. So let's see what you got. This would be 4 times 3, which is 12. That's the area of the yellow rectangle. And the 4 times the 2, which is 8. That's the area of the blue rectangle. Add these two areas together, and guess what? You get 20. All right, so here's your job. Your job is to try problem 3. All right? Use 1 and 2 above as models. In this one, though, they don't have the area models. So, reminder, the first one, you're going to add what's in parentheses first and solve it. And this one, you're going to solve the 6 times the 20 and the 6 times the 3 and add those two amounts together. You should, if you do it right, get the same thing on your equal to lines. All right, pause the video, try it, go. All right, guys, how'd you do? So check your work as I go over it. Pause the video to fix any mistakes. So in this first one, did you add the 20 and 3 to get 23? And did you do 6 times 23? I guess I didn't say you couldn't use a calculator, so I guess you could have. If not, you should have 138. Now, if I do this right over here, I should also get 138. Let's see if I do. First off, did you do 6 times 20, which is 120? 6 times 3, which is 18. 120 plus 18 is 138. All right, so that's it for the first one. Now, before we go to 4 and 5, we have to go back a page, the next page, and we're going to do one of these together. So this says in number 4 to use algebra tiles to tell whether the two pairs of expressions are equivalent. So here's what we're going to do. We're going to split this box in half. Do this one with me here. And we're going to start by writing this one on the left, 3 times x plus 1. And then we're going to write this one on the right, 3x plus 3. All right, so now we're going to start and we're going to draw this expression. Remember, this means 3 groups, because it's 3 times x plus 1, 3 groups of x plus 1. So let's draw that. Here's an x plus 1. There is one group. Here's another x plus 1. That's a second group. And here's another x plus 1. That's a third group. So right here we have 3 groups of x plus 1. Group 1, group 2, group 3. Now to see if it's equivalent to this expression here, we have to group all of our x's together and all of our 1's together. So over here, let's take our 3 x's. Here's 1, 2, 3, and draw them all next to each other. 1, 2, 3. Now we're going to take our 1's and group them next to each other. So there's 3 of them. So I have 1, 2, 3. And now notice what I have. I have 3x, that's this here, plus 3. That's this here. So guess what? These are equivalent expressions. Now, just so you know, you are simplifying this blue expression in simplest form. And that's what it's going to look like in simplest form. All right, now one more. I'm going to start you off with this one. We are going to see if this expression, 2 times 3x plus 2, is equivalent to this expression, 6x plus 4. Now I'm going to give you a choice here. If you think you can do this based on when we did number 4 together above, then I want you to pause the video and do it. If not, if you don't think you can do it on your own, you can do this with me. Or you could pause it at any time and, once you think you can do it. So I'm just going to start you off. Remember, if you want to go ahead and do this, pause it and go ahead and do it and then check. I'm going to start us off, though, by drawing what this means. Remember, this means 2 groups of 3x plus 2. So I'm going to draw 3x plus 2. Remember, that's one group, but this says I have to have 2 groups. So I have another group of 3x plus 2. So here are my 2 groups of 3x plus 2. Now, if you're doing this with me, here's another chance that you can pause it, because you can always, remember, to go over here, you're going to group all of your x's together and all of your 1's together and see if it equals this. So if you want to try that, pause it and do that now. If you're still having trouble, you can stick with me here. All right, so let me switch here. I'm going to start over here by regrouping my 3x's and 3x's together to get 6x's. So I'm just putting all of my x tiles next to each other. Okay, see my 6x's, 6x. And then I'm going to take my 1's. There's 2 and 2, which is 4. I'm going to group those together. So I have 6x plus 4. So guess what? That means yes, they are equivalent. All right, ladies and gentlemen, you are officially done with me. So don't be too confused by this, because this is going to help you with the lesson we're doing tomorrow. If you have any questions, though, make sure you ask me. As always, thanks for watching.